morning, everyone, and today I will continue my Google AI for anyone studies. So let me share my screen, or to be more specific, let me share my window. I hope it works. Let me slightly increase the size of my video. Yeah, that will work. Yep, that looks nice. I hope it's all working. Let me check if my streaming is working. I think it's working. And I think YouTube is working. Well. You do some works on the YouTube channel. Okay, good stuff. Now, hope you see it. So the course is called Google AI for Anyone. And today we are going to try to get more than 12% of completion. So let's see. So earlier I have, we have learned the difference between traditional programming and AI programming. The idea is that in traditional programming, we define the rules, and in this approach, we provide examples and data and answers. So, like in tic-tac-toe, we provided the data of different combinations and different setups, and then we told which one is a good solution and which one is bad, something like this. So, sorry for this chair. Need a new one. So let's see. The AI revolution resulted from an innovation that allowed programmers to build applications that took in data as examples and figured out patterns in the data to solve complex problems. Take a look at the illustration of machine learning. Yeah, that's good. So what we need is rules based on data and correct answers. I'm not sure we'll go for the certificate because, well, $200 for basics, it's a bit too much. So, yeah, this one is clear. It's good. To be honest, that could be replaced just with this image. Okay, so this one is interesting. Well, this one will be especially interesting. So lots of data and patterns. That's okay. The Schultz example has been explained before. So overfitting. Yes. Okay, interesting. So we might have an issue when we train a system using partial or insufficient data. That's quite interesting because that might be the case when you use for example, just one type of images. For example, a white man to train a face recognition system, and then it actually it's not fit for purpose, and it basically acts racist because AI cannot recognize people who are non-white men. So, well, it recognizes them worse. So yes, so if you give a non-representative data, then it will only work good with non-representative results. As soon as you switch to realistic results, it becomes it starts behaving it becomes incompetent basically. So, yeah, there was an example of AI model which can recognize human retinas and, for example, tell person's age, which even a professional doctor will have problems with. Okay, so they're reminding us that it will be nice to buy the certificate. No, um, not at the moment. I'm not sure what exactly will it give me. I can add to my resume that I've audited the course, but exam, why would I? Um, Maybe if there was a voluntary donation, like let's say $10 for auditing the course, maybe I would have done that. But paying to kind of a certificate. So yeah, we use label data and computer algorithms to match data to the labels. Okay. So then we'll have a model which will be able to label new data. So like in the previous example, there was data which showed what is a shoe, and then later when you get a shoe picture to this model, it could recognize if it is a shoe or not. I know this is a naive example, but it is still important and it works. So you're recognizing if it is a cat or not, if it's a dog or not. This can be quite useful in well, in a lot of industries, protecting from different types of unwanted images, for example. You'll explore how this works with teachable machine from Google. Yeah, that's good. Access the teachable machine from, 1 second, check something. Yeah, let me just quickly check. Yeah, I look okay. Yeah, I have second screen with my uh, with the data on the stream. Okay, so we can access virtual machine on my computer or laptop to complete the interaction activity. We'll be taking to a site outside of the course and the EDX platform. There'll be slides, but yeah, let's do it. And let's go to the let's see. What data will you use for training a model to identify numbers of vehicle license plates? So obviously we'll be feeding images of license plates. Well, I think so because just the values it's not enough. I need it to be able to recognize values on different license plates because they look differently. Yay, that's the correct one. And we just achieved, I guess, one more percent. Did we? Yeah, it's 13% now. Train a computer to recognize your own images, sounds, and poses. Get started. Image project. Okay, let's do images. Oh, interesting. I never done that. Okay, and what should I do? I will temporarily move to another screen because, well, I don't want any private data to be shown. Yeah, that's what I thought. Okay, so let's go back. Okay, cool, got it. Let's go back. So if I go to new project, and if I go to, you just click here. I expected some button to appear, but you just click. It needs image samples. Let me get you some images. It would be nice to see some slides first. I really do not know how it should work. Let's say we get a few. Oh, sorry. Let's say we get a few cat images. Okay. Uh, Cat dataset at Kaggle. Download. Oh my God, it's 4 GB cat dataset. Um, like, like really, I'm not joking. This one. Uh, well, we can probably just get some of them. Okay, I'll get us some cats. And 1 second. Just cats. Oh, 1 second. And I'm just saying some cats. Oh, they are beautiful. Although it really depends on the culture. In some cultures, cats are not beautiful. Well, they're not considered beautiful, but still, it can be used for the data. I will turn off the screen sharing for a second because I don't want to show anything which shouldn't be showed. Stop sharing. Now, yeah, that's good that I didn't. Stuff I can share again. So basically, when you click here, you can just download, upload different cat images. So yeah, now that you have two classes, you can train your model. Oh, that's an example of training the model. So let's see. Let's see if I can allow the audio from. Uh, if I'm not sure how to allow the audio from the screen, but I will turn on the captions and we'll see. We don't really need audio. So to be edit data, training the model, don't switch tabs. Okay, so the model gets training data. Something is happening. I would assume that labels are being edited. Let's see. So that's how teachable machine from Google works. Well, I assume it's Google, though I'm not sure. Then, oh, and then you can see how it actually works. Okay, cool. This is still nice. Thank you very much. Now let's click train the model. I know it's just two pictures. It wants to use my cameras. No, thank you very much. Oh, oh, yeah, maybe some other day. But yeah, I have an idea because it wants to use my camera and I'm streaming. But if we were checking the under the hood, for example, this thing. So what does it show? Accuracy, confusion matrix, and so on. So I'm a bit tempted to download 4 GB from Kaggle now, just for research purposes. So let's actually see. Get images zip. So as you can see, if I go to cat dataset here, it's 4 GB. It wants me to sign in. 1 second. Wants me to register to Kaggle. Okay, and hopefully now I can download. Yeah, I'm downloading the cats, all 4 GB of cats. So we will never have not enough pictures now. Oh, it's peaceful. So let's see further. Oh, we have a graded quiz, don't we? And what is our progress? Still 13, I assume, because it's not integrated with teachable machine thing. So identify the statement that represents the machine learning paradigm. So data plus answers. It will create us a machine learning model, which will have rules which we can use to process data further and get our answers. Yeah, we are correct. What would be the labels while training the teachable machine to detect rock, paper, scissors, hand poses? Yeah, labels will be the classes because this is just an image. But if you define that picture that this one is actually a rock, then the rock will be the label because you can say it's a star. It will be totally different discussion. What would you use to train the teachable machine to detect rock, paper, scissors? Yeah, we'll use the real images and we'll just say if it's correct in recognizing them. Identify the correct sequence of steps you follow to train the teachable machine to identify rock, paper, and scissors hand poses and use it on a web page. Okay, train the model with the labels and data. Test the model with a sample hand pose. I would say 3 goes first. It, oh, it's talking specifically about this thing, teachable machines. So I would say 3. First, we create classes and create data, then we train the model, then we test. So it will be 3, 1, then we test the model, and then we export the model. Yeah, we are correct. Interesting. Does it check our progress on? Yeah, it checks it on the atomic level. So whenever we complete a question, whenever we answer a question, it affects our evaluation. Okay. Oh, now we have video applications. So let's see. We have there. Oh, it's 4 minutes. 4 minutes is a bit lengthy. Um, Let me see if I can get transcription. So that's Lawrence Lawrence Moroni, amazing person, and yeah, so really recommend to check out his LinkedIn and to actually to do this course. So let's quickly see what he's talking about. Can I? increase this thing somehow? Because I'm mostly interested in this because I read faster than I watch. Okay, so yeah, it's talking about the importance of using AI for, well, models for working with huge amounts of data because it allows us to make important decisions, like regarding the health. Yeah, computers to images on pixels, that's fine. Example here, right? Uh, so, talk about filters. That was actually here. Yeah, so here's showing how filters are working. This pictures. Okay, I'll pause it. So program's job is simply to write code that handles all of those filters and algorithm for learning them. Okay. Okay, so we are creating a set of filters to recognize what's going on in the pictures. Okay, that's interesting. Is it plus 1 more %? Not yet. Shouldn't I? There is no button like complete or something. Or do they actually expect me to watch till the end? Let's see. Uh, if I was, will it affect? Yeah, they actually expect. So this course completion expects us to watch videos. A key application of AI is a computer vision, where you can train a machine to identify content in images. Okay, that's similar to how people process images. Good stuff. Let me just quickly check if everybody's. Uh, yeah, all zero of my viewers are happy. That's important. To Well, my goal is just to continue studying this stuff. It's much harder to quit when you are sharing it. Now, so we're talking about the data. I don't really need to know this stuff. Well, in terms of like medical, I just want to understand how. So we label images as healthy or diseased. That's all right. And the application then attempts to extract features from the image using filters. During the training process, the application learns the best filters that change images. Sorry, it's 7:30 in the morning on Sunday. That's the only time I can actually stream on the weekend. Um, so at some point we'll have a set of filters which will help us to recognize which one is healthy and which one is diseased. Okay, so we store images as pixels. That's fine. We create filters. That's fine. Um, okay, so when we apply the filters on the grid, it's used to multiply, right? by corresponding value in the filter. So if we have all the 9 resulting values are summed up. Yeah. So interesting. It's again, it reminds how cool it will look on my wall of. Well, I do not put any diplomas on the walls. Why would I? But for now, did we get 1 more % just for reading this thing? Oh, 2%. That's interesting. This course is not hard at all. Everyone can, yeah, as they promised, AI for anyone. So we'll have this huge jumper. Move. Use your mouse at the bottom of the screen. Move mouse to steer. If you're going too fast, okay, yeah, whatever. Why not? I'm using a trackball, but let's see if I can do anything. Oh, we crashed. No, there's a tree. So at 1000, we'll actually. Oh my god, this is not that easy. Not with a trackball. Oh, yeah, okay. Yeah, I'm not really inclined to playing games. Thank you very much. Let's go next. Well, I went to 100 something. Oh, so there were breaks. I didn't know that. Oh, I didn't really want to play this game. That's a lot of rules. So yeah, that's the problem with old computer games that we had to program the rules, but we kind of as a human we didn't really learn into the rules. We just did it, and we managed to get our incredible 100 plus points. So yeah, let's add a post. Why not train using videos and not just use videos of great versus bad game will probably be more useful to AI, given it has good enough computational abilities. In such recording, there will be not just an image, but data associated with it, timestamp, other uh, moments in the race. Let's call it not a game, let's call it race. Submit. Well, I don't really want to follow. Yeah, whatever. Well, I don't really want to follow now because it's, although there's some, yeah, there's some communication going, but I haven't seen many courses which um, succeeded to create relationships between people. I haven't seen many cases when people discuss something there and it became a project. Discussion participation grade quiz. Online driving game. Report your participation in online driving game discussion forum here. Yay. Oh, we need to respond to 2 posts. Uh, well, We are to figure as we play. Okay, uh, that's a good point. Now we can click this button without lying. Yes. Thank you very much. We got one more point. We should bet 18 now. Or maybe even 19. 19. Let's make it 20. I'm not sure how we expected to spend 3 or 4 weeks of our lives on that because it's a bit easy, but we'll see. So, to be honest, I'm not really inclined to watching this. I will uh, basically, well, first, I don't want to get into problems of showing the whole of this video because, well, what if I cannot? And second, I expect this data to be enough, and that will speed up the course. To train a computer to play an online video game, driving game, program must have to provide multiple images or frames of what the driver would see. Okay, so we'll give images and we'll tell what should be done. Left and right, gentle to the right, straight brake. Then computer will know what to do according to the image. That's interesting. It's probably how they train Tesla. More complicated than that, of course, more detailed, but they might be the same. Okay, they remind me that I haven't yet bought the certificate. Well, bought the course. Oh, we are all 23. And we are going to play this tic-tac-toe, I think. Mm, 1 second. Oh, somebody gave us a star. Somebody was very kind. Thank you so much, friend. Not a star, a bulb. We have a light bulb on our stream on LinkedIn. Okay, thank you. For this interactive session, you are going to play some games of tic-tac-toe. You can try it anywhere, but it's really okay. Not really inclined in doing this. Have someone think of how to play this game? Okay. Yeah, so again, the game. Not really interested. Yeah, so there's a case that when we play tic-tac-toe, if we do not put our cross in the middle, then computer might also not use the center. And I would say that's because of the data, because normally when the first player starts, he or she or them will put the cross in the center. Uh, so all the data given to the AI, all the training data will start with the center thing, but it will really lack the knowledge of what to do when the first player does not start from the center. So yeah, that will be the explanation. Oh, so developers didn't program the rule to take the center if it's available. And that's the problem again with making like with having not enough data, not enough varied data. Why didn't it give us a tick here? Okay, let's see how much have we achieved. Is it 26? Okay, video machine learning for tic-tac-toe. So some games. Thank you very much. Okay, good. And I think that's it. We made like 28%, 29. Oh, let's just do a bit more. So we'll get to 30 and then we can call it a day. And then hopefully this week we'll finish the course. And that will be fabulous. Okay, so in this example, we didn't program, but we trained the machine to play tic-tac-toe. Okay, and explains how the training was working, so that's fine. Yes, so interesting. So we need, I guess, to give it respond to two posts. Well said. Somebody really spent time on the on doing that, or on replying to, on writing a post. Sorry. Well, interesting. So high discussion. How do I go back to the discussions? Tic-tac-toe. Okay, previous. And they're asking me to do it, my own post as well. So add the post. What about 3, 4D, 4D tick? Who would win in MD is in 4D tick tack toe? What about 100D? So yeah, that will be interesting. What? Yeah, we do not really want to follow. Submit. And here it's just an honest answer. I don't think they're checking data. And are we over 30? Yes, we are exactly 30%. That's good. So yeah, so thank you very much for attending, and we'll continue hopefully on Monday. So the goal is to do this course and then to do other courses, as you can find in my LinkedIn. One second, I'll try to find. Oh, actually, I have the link. So as you can see in my articles here, all we are doing, we are checking those certifications from this article by checking the certifications one by one. So currently we're doing Google AI for everyone. I would really love to complete it this week. Ideally, let's say by Wednesday evening, and then we could switch to the amazing Howard's introduction to AI with Python, and that will be interesting. Uh, how much would the certificate cost on this one? That's also 300. So yeah, and so we will have quite a lot of them. You don't have money for buying all this stuff. But yeah, I'm not sure the certifications on themselves they pay well, but by doing them, we will learn the ecosystem around. So for example, NVIDIA AI certifications, they might have quite a lot of them. So, oh, they even have learning paths. Now I'm interested. Um, AI enterprise, that will be probably mine path. That's now we're talking. It's interesting, but we'll just go course by course and we'll manage. So, yeah, thank you very much. And let's meet later. And thank you all. And have a really nice Sunday or any other day of the week.